thousands of years before modern machines, ancient civilizations were creating technologies that still leave us with difficult questions. They shaped massive stones with astonishing precision, engineered structures that have survived for millennia, and developed techniques that seem far ahead of their time. But were these truly impossible technologies, or have we simply misunderstood how ancient people achieved them? In this documentary, we'll examine the evidence behind some of the most remarkable engineering achievements of the lost civilizations. Somewhere beneath the sand of a desert plateau sits a stone block heavier than a jumbo jet, cut with a precision that modern machinery would struggle to match, moved without wheels, without iron, without any machine we can name. Nobody living today knows exactly how it got there. That single unanswered question is the doorway into one of the strangest puzzles in human history. The ancient world built things we still cannot fully explain, and the deeper archaeologists dig, the stranger the story becomes. For most of us, the story of technology feels like a straight line. Stone tools led to bronze, bronze led to iron, iron led to steam, and steam led to silicon. Each generation, we assume, is smarter and more capable than the last. But when you actually walk the ruins of the ancient world, that tidy story starts to fall apart. You find 20-ton blocks fitted together so tightly that a piece of paper cannot slide between them. You find cities engineered to survive earthquakes that flatten modern buildings. You find devices so mechanically advanced that when they were first discovered, scholars assumed they had to be a hoax. The people who built these things did not have cranes, combustion engines, or computers. And yet again and again, they solved problems that still humble engineers with all of that technology at their disposal. Start with the pyramids of Giza, because nothing captures this contradiction better. The Great Pyramid of Khufu was assembled from more than 2 million blocks of stone, some of which weigh as much as 80 tons, quarried, transported, and stacked into a shape that rises almost 500 feet into the sky. The base is leveled to within a couple of centimeters across a footprint the size of 10 football fields, and the whole structure is oriented to true north with an accuracy that surveyors using modern instruments still find impressive. Egyptologists generally agree the pyramid was built as a royal tomb and monument during the reign of Khufu, using ramps, sledges, levers, and an enormous coordinated labor force, evidence for which has been found in nearby workers' villages, complete with bakeries, medical facilities, and payrolls. That is the accepted evidence-based explanation, and it is remarkable enough on its own. What keeps the mystery alive is the precision. The internal passages are cut with tolerances that seem almost obsessive for a monument meant to be sealed and hidden forever. And no widely accepted account fully explains how workers lifted certain multi-ton granite beams into place so high above the ground. Different engineers have proposed different ramp systems, internal spiral ramps and lever-based lifting methods. And the debate over which combination of techniques was used is very much alive within mainstream archaeology itself. The honest answer is that we do not have a single confirmed blueprint, only strong, competing hypotheses. Now travel north to the Bekaa Valley in Lebanon, to a site called Baalbek, and the puzzle gets heavier, literally. Underneath the Roman temple complex that once stood there lies a stone platform built from blocks, so large they defy easy categorization. 3 of them, known together as the trilithon, each measure around 60 feet long and are estimated to weigh somewhere between 800 and 1,000 tons apiece. Nearby, in the same quarry, sits an even larger stone, sometimes called the Stone of the Pregnant Woman, and beneath it, discovered more recently, an even bigger block still attached to the bedrock, estimated at well over 1,000 tons. To put that in perspective, moving a load like that would challenge the heaviest cranes operating today. Roman engineers were extraordinary builders, but there is no surviving Roman record describing how a stone of that mass would have been quarried, transported nearly half a mile, and lifted 20 feet into a wall with the kind of accuracy seen at the site. Most archaeologists believe the platform predates the Roman temple and was incorporated into it, built by earlier Phoenician or other regional builders using techniques that simply were not written down or did not survive. It's a genuine unresolved question, not because the stones are impossible to move with enough people, ramps, and time, but because we lack direct evidence of exactly how it was actually done at this specific site and scale. Halfway around the world, high in the Bolivian Andes, sits Pumapunku, part of the ancient Tiwanaku civilization. What makes this site so striking isn't just size, it's precision. The stone blocks, some made from andesite and diorite, some of the hardest rock on Earth, are cut with flat surfaces, sharp 90-degree angles, and interlocking joints that look closer to industrial machining than hand carving. Some blocks feature small, evenly spaced drill holes and grooves only a few millimeters wide. Archaeologists studying the site generally attribute this work to skilled Tiwanaku stonemasons using stone hammers, abrasive sand, and copper or bronze tools, combined with an enormous investment of time and labor, sometime around 500 to 600 AD, though the exact dating and methods remain debated within the field. What's undeniable is the technical sophistication involved. Working diorite by hand, to that level of flatness and symmetry, without modern cutting tools, represents an extraordinary mastery of material science, patience, and geometry, whatever techniques were ultimately used. Precision and scale aren't the only forms of ancient genius, though. Some cultures solved a different problem entirely: how to build a thriving city in a place that seems to actively fight against human survival. Machu Picchu is the perfect example. The Inca built this city on a narrow mountain ridge nearly 8,000 feet above sea level, in an earthquake-prone region that gets pounded by heavy seasonal rain. Instead of losing that battle, Inca engineers turned the mountain into an ally. Around 60% of the construction at Machu Picchu is actually underground, an enormous hidden foundation of packed stone and gravel designed for drainage and stability. The above-ground walls are built from interlocking polygonal stones fitted without mortar, so precisely the knife blade cannot slip between them, and this design allows the stones to flex slightly during an earthquake and settle back into place rather than crack. A network of stone channels carries spring water through the city at a carefully calculated gradient, feeding a series of fountains that, remarkably, some of which still function centuries later. None of this required exotic technology. It required an intimate generational understanding of geology, hydrology, and structural engineering, developed entirely through observation and experience, without metal tools, the wheel, or a written language, as we define one. The Romans, meanwhile, mastered a completely different kind of engineering: infrastructure at civilizational scale. At its height, the Roman Empire maintained a road network stretching over 250,000 miles, connecting territory from Britain to North Africa to the Middle East. These roads were layered structures, built with drainage in mind, engineered to stay usable through centuries of traffic and weather, and some sections are still walkable today. Roman aqueducts carried fresh water across valleys and through mountains using nothing but gravity and precisely calculated gradients, feeding public baths, fountains, and one of the ancient world's first large-scale sewer systems. Perhaps their most underrated achievement was their concrete. By mixing lime with volcanic ash, Roman engineers created a building material that, when it came into contact with seawater, actually grew stronger over time through a chemical reaction that modern researchers have only fully understood in the last decade. That concrete is why structures like the Dome of the Pantheon in Rome, still the largest unreinforced concrete dome on the planet, have survived nearly 2,000 years without steel reinforcement. Then there's a device that, more than almost anything else on this list, forced historians to completely rethink what the ancient world was capable of: the Antikythera mechanism. Recovered from a Greek shipwreck in 1901, this corroded lump of bronze sat in a museum for decades before researchers, using X-ray and CT imaging in the 21st century, revealed what was actually inside: a system of at least 30 interlocking bronze gears, some with teeth cut to a precision of a fraction of a millimeter. This device, built somewhere around the 2nd century BC, could track the position of the sun and moon, predict eclipses, and even account for the irregular orbit of the moon using a clever differential gear system, a mechanical concept many historians assumed hadn't been invented until the 14th century in Europe. Nothing of comparable mechanical complexity appears again in the historical record for well over 1,000 years. It stands almost alone, a level of engineering that seems to arrive from nowhere and then vanish. And it remains one of the strongest pieces of physical evidence that at least some corners of the ancient world had reached a level of mechanical sophistication we still don't fully understand the origins of. Technology in the ancient world wasn't only about stone and gears, either. Sometimes it was about chemistry that later generations simply lost. The Byzantine Empire's famous weapon, Greek fire, is one of the best documented examples. For centuries, it gave Byzantine naval forces a devastating advantage, an incendiary liquid that could be sprayed from shipboard tubes and would continue burning even on the surface of water, making it almost impossible for enemy sailors to extinguish. The exact formula was treated as a closely guarded state secret, passed down through a small number of trusted individuals, and it appears to have died with the Byzantine state itself. Historians have proposed several plausible recipes, most involving some combination of crude petroleum, pine resin, and sulfur, but no one has definitively recreated the original substance, and it remains a genuine case of documented ancient technology that outpaced the record-keeping meant to preserve it. What ties all of these examples together isn't a single hidden civilization or a secret lost superpower, even though that idea makes for a compelling story. What ties them together is something arguably more impressive. Different human societies on different continents, with no contact with one another, independently arrived at extraordinary engineering solutions using nothing but observation, trial and error, immense patience, and generations of accumulated, often unwritten knowledge. The Egyptians solved problems of scale and alignment. The builders at Baalbek and Pumapunku solved problems of mass and precision. The Incas solved problems of adaptation and seismic survival. The Romans solved problems of infrastructure and material science. And whoever built the Antikythera mechanism solved a problem of mechanical computation that wouldn't be matched again for over a millennium. It's worth being honest about where the real mystery actually lies, because it's easy for these stories to get inflated into something they're not. The mystery isn't usually whether these structures could have been built by ancient people. In most cases, modern engineers and archaeologists have proposed workable methods using tools and labor that we know these societies had access to. The genuine mystery, in most cases, is which specific method was actually used, because so few of these building techniques were written down, and because so much supporting evidence has simply been lost to time, erosion, conquest, and the collapse of the societies that held that knowledge. That's an important distinction, because sensational claims of impossible construction can end up erasing the real achievement, which is the sheer human ingenuity involved in solving these problems with the tools available at the time. These builders weren't primitive. They were extraordinarily skilled specialists working within civilizations that had their own institutions, their own accumulated science, and their own deep practical understanding of the physical world. Even if that knowledge doesn't always look like science the way we define it today, there is still so much we don't know. We don't know precisely how the largest stones at Baalbek were lifted into place. We don't know exactly how Pumapunku's stonemasons achieved such precise cuts in some of the hardest rock on the planet. We don't know who built the Antikythera mechanism, or how much of that mechanical tradition existed before it and was simply lost. And we don't fully know how a small number of extraordinary construction techniques appear to have been independently discovered by cultures that had no way of communicating with one another. Modern tools like ground-penetrating radar, satellite imaging, and 3D laser scanning are slowly filling in some of these gaps, revealing hidden chambers, buried foundations, and construction details invisible to the naked eye. Every few years, a new piece of the puzzle turns up, and each one tends to complicate the old, simple story rather than confirm it. Maybe that's the real lesson buried in all of this stone and bronze. Progress has never actually been a straight line upward. Knowledge gets built, refined, passed down, and sometimes it gets forgotten entirely, only to be rediscovered centuries later by someone who has no idea it already existed once before. The people who quarried, carved, and assembled these monuments were not lesser than us. In many specific, narrow ways, judged purely on the engineering challenges they solved with what they had, they were our equals. and in a few remarkable cases, they may have briefly been ahead of us. The stones are still standing. The mechanism still turns. And the questions they leave behind are just as alive today as they were the moment archaeologists first uncovered them.